Okay, so welcome to the stream and howdy doody. What was I saying? Made a mistake here. Where is my? No, we're fine. Yeah, I was gonna start streaming again like hours ago, but I made a lot of excuses. I did not start again. I think what was I doing? I streamed early in the morning, got food, and then just spent hours doing, well, I guess just browsing the internet. And spent some time laying down, kind of had some time to think. What else did I do? Just did a bunch of stuff. But yeah, there was a podcast I was listening to for about an hour, which was really good. It was hard to not listen. And then there's all these things that I wanted to look at and listen to and check out. It's hard to pull myself away from all of that. Visions of a different life, a glimpse into a different life. That's what I was looking at. But I've got work to do. Like, I know I've got this thing to do first. And once I get it sorted out, once I finish all these problems, learn Clojure, kind of get more comfortable with it. Once I do that, then I think I was talking with someone else, a viewer who was talking about using reduced in Clojure, and he was suggesting that it should be used infrequently. I'll have to remember that for the future. Anyway, so yeah, I mean, it shouldn't be too hard to get through these problems. So there's a part of me that's kind of like daunted because I've got these ideas now of things that I can do, like sort of plans, sort of quote unquote plans for the future, to make things, do things right. And I'm kind of all over the place, I guess. Somewhat, I suppose. My mind has been. Well, anyway, let's get back to these problems. But yeah, that's sort of why I'm late. That's my excuse. That's why I'm late. It's because I try to do things. I want to try to spend maybe like 3 hours. Let's try to get in here. Maybe we'll do 2 hours, then take a break. It's around 7:35. Yeah, that's okay. I mean, we'll get time. Get the time in. We get the time in. Write a function which calculates the least common multiple. Your function should accept a variable number of positive integers or ratios. Hear the TV on. So interesting thing about the least common multiple is if you multiply all the numbers across, then that will be equal to the greatest common divisor multiplied by the least common multiple. That's kind of a, what do they call that? Say consequence. But if you're dealing with only integers. I don't know what you would call that. A reality? I don't know. Tricky thing though is a couple things about that though. So that's one way of calculating the least common multiple, is just calculate the GCD and then divide that by the product. Divide the product by the GCD. Tricky thing though is I don't really know what GCD would be if you're dealing with multiple or ratios. I actually don't know. Excuse me. This is easy. What would be a least common multiple? How would you calculate that directly? I don't know of a way to calculate it directly. That's what I would do, is I'd calculate the GCD and then use that to get the LCM. If you multiply these two together, No, that doesn't work. That's kind of interesting. You get 2/15ths, and then you divide that by, I guess, 1/15th, and that will give you 2. The GCD is 1/15th of these two. How would you get 1/15th of the GCD? I guess you would say, like, how did you do GCD of ratios? How does that work? Something that divides both of these. I guess you could take whatever you want for a GCD if you're dealing with ratios, right? Like, it doesn't really make sense anymore. Greatest common divisor. Least common multiple is just the smallest number that if you multiply sort of x by some k, you can get that multiple, and then y by some other k, you can also get that multiple, and it's the smallest such multiple of those sets. It's kind of like a Diophantine equation, I think, I guess, I suppose. Could be considered a Diophantine equation. Could be rephrased as the answer to a Diophantine equation. So you can multiply 1/3 by 6, and you can multiply 2/5 by 5. Are these things even remotely related to the denominator, though? I'm not sure what to think of all of this, make of this. What to make of this? I don't know how to calculate the least common multiple. Alright, we'll look it up. Not something I know offhand. Excuse me. The lattice of divisibility. Interesting. Unique supremum and unique infimum. Lattice. I don't use that too often. The join or the meet. Natural numbers partially ordered by divisibility. Unique supremum is the least common multiple, and unique infimum is greatest common divisor. Huh. Partially order your natural numbers by divisibility. The unique supremum over a set would be the least common multiple, and the unique infimum is the greatest common divisor. I don't really understand this here. I feel like you could just call both of these things the bottom and the top of a lattice, if that makes sense. Like, it's not clear to me that this must be, like, there's got to be a supremum of a certain set, I guess. Actually, yeah. Well, the way supremums and infimums work is that they're the supremum will be the largest possible value. Okay, no, I guess that makes sense. I think I understand now. The largest possible value such that, oh, okay, I get it. No, this makes sense. Okay. So being partially ordered by divisibility means that A is quote unquote less than B. I guess if and only if A is divisible by B, or A divides B, we'll say. So that's what they mean by partially ordered by divisibility. You can create sort of a relation. You know, A is related to B if A divides B, and quote unquote partially ordered. Partially ordered means it's got a few different special properties. One of them being transitivity. And so there's a notion. There can be a notion of like a smallest value, kind of a deal. And there's a notion of things being less than each other, right? And the suprema means that it's the largest possible value such that suprema means the smallest possible value such that everything in the set is less than that value. So if you took a subset of the natural numbers, and then ordered them with respect to divisibility, the least common multiple would be the smallest multiple, where everything in the set divides this value, right? And then conversely, the infimum is the other way around. It's the largest possible value that's smaller than everything else. So this divides everything in this set, hence greatest common divisor. There might be other common divisors, but they would be smaller than the infimum. And so they're not the infimum. They're just, common divisors. Yeah, okay, makes sense. Very interesting. I think I get it now. I think I understand. So it's an abstract structure, has a partially ordered set in which every two elements has a unique supremum and a unique infimum. So that's a lattice. Interesting. Okay, now I get it. Took a while, but I got it. Took a while, but I got it. Can also be characterized as algebraic structures satisfying certain axiomatic identities. Since the two definitions are equivalent, lattice theory draws on both order theory and universal algebra. Semi-lattices include lattices, which in turn include Heyting and Boolean algebras. Interesting. These lattice-like structures all admit order theoretic as well as algebraic descriptions. Lattices can also be characterized as algebraic structures satisfying certain axiomatic identities. Since the two definitions are equivalent, lattice theory draws on both order theory and universal algebra. Semi-lattices include lattices, which in turn include Heyting and Boolean algebra. These lattice-like structures will all admit order theoretic as well as algebraic descriptions. Order theory and universal algebra. Interesting. So you can consider them algebraic structures that satisfy axiomatic identities. Really? I don't really understand what this means in the first place, though. So they could be both. They could be partially ordered set with a supremum and infimum, right, with a unique, right? Or they could be considered an algebraic structure that has identities, certain axiomatic identities. Huh. Well, that's weird. I mean, I'm just totally unfamiliar, Explain more, maybe? And then there's something about semi-lattices. Well, I don't want to know what lattices are first before trying to figure out what semi-lattices are. And I don't know what Heyting or Boolean algebras are. I mean, I can guess about Boolean algebras, but I really don't know. I'm not really super familiar with these things. Oh, they're both algebras. Oh, okay. I think I may have studied, Heyting algebra in uni, because I see this cross to the right symbol. I recognize that from one of my courses at university. Cool. Anyway, I don't fully understand, but I need some time. You know, I could spend some time and try to understand what they mean, what they're getting at. Lattices. But that's cool. So anyway, some define the LCM to be the least upper bound in the lattice divisibility. Okay, this is the infimum of the lattice divisibility. I mean, whatever. That's okay. Lowest common denominator that can be used for before fractions can be added, subtracted, or compared. Oh. The LCM of more than... Oh, yeah, this is kind of cool. So, oh, is that what they want? If you're using fractions to get... So, the LCM, least common multiple, is the lowest common, right? Basically, when you multiply 3 and 15, 3 and 5, you get the lowest common... Oh, actually, this is a lot easier than I realized then. Oh, I get it now. Duh. I forgot about that. Yeah, okay. So if you want to add fractions together, you need the least common multiple of the... you first need to reduce the ratio, these fractions down to the simplest form, and then take the least common multiple of the denominators. But we can use, but then we have integers to work with, so then we can get the least common multiple by using the GCD algorithm, and then we get the least common multiple, which then gives us 1/15 would be what we need to get. So then 1/15 of the fractions is the greatest common denominator, sort of the fractions, which then gives you the inverse. So if you multiply these two and then divide by that value, then you get 2, which is kind of funky to go through all that like manipulation, but that's pretty much what you need to do. You get first you get the GCD of these. First you got to make sure these are least common, lowest, most simplified form, which I think in Clojure the ratios are naturally. I think as soon as you create it, it will automatically become lowest common form. I have to check though what the deal is. Simplest form. So you have the simplest form of the ratio. Take the greatest common denominator of the greatest common denominator of the denominators, greatest common divisor of the denominators, then multiply across the denominators, divide by the greatest common denominator of those denominators. That'll give you the least common multiple of the denominators. Then you're actually going to divide by that number, and you're going to multiply by that number, and what you're going to multiply that to is the multiplication of each of these values. So you multiply these things across these ratios, and then multiply these ratios across, and then divide by then multiply by the, or divide by, really it'd be multiplied by the division of the GCD into the product of the least common of the denominators. Yeah, a little bit confusing, all of that, just a little confusing. Not sure why this is considered an easy problem exactly, because that's kind of a lot of manipulation. Maybe there's a really simple shortcut that you can do that I'm missing. But yeah, so when you multiply these across, you end up with, does it work for these things? So if you multiply these across, you get, let's see, this will be so 7 times 5, right? Then the GCD of 7 and 5 is 1, right? So now you got 35. You're going to take 1 over 35, right? And then, so dividing by 1 over 35 is equivalent to multiplying by 35. And you're going to multiply this by all of these things multiplied across. 5/7, we'll just say 5 divided by 7 times 2 times 3 divided by 5. Yeah, that seems to be the correct answer. So, funky as that is, if you don't have any divisors, any denominators, then you could convert all of these to ratios over 1 and apply the same formula. So if you did that, ratio over 1, what it would look like is greatest common, multiplying all those things by 1, then taking the greatest common divisor of those things. Hold on, let me think here. Multiply those things by 1 over 1. Greatest common divisor of a whole bunch of 1s is a 1. The multiplying all those through is a 1. Dividing by 1 into the other is a 1. And then dividing by that is multiplying by 1. So you multiply 1 by 5 by 5 by 3 by 7. Which gives you the right answer here, but if you had something like 10 by or 14, or let's do even better, like 9 by 7. 189. 9 by no, you want to do, like, let's just multiply everything by 2. So you have 10 by 6 by 14, right? The greatest common divisor you should divide this by 2, right? Because you two factors in each of those. So your greatest common divisor would be 420. Problem is I don't actually know how to fix that with respect to the ratios. How could you fix that with respect to the ratios? Like if you had 5 halves, 10 halves, and 15 halves, right? 5 divided by 2 by 10 divided by 2 by 15 divided by 2, right? Do something like this, right? You get this whole thing. Then you're going to multiply this by 2. Well, excuse me. Least common multiple of 2 by 2 by 2, we end up with 8, right? Where does this even go? We end up with, okay, we end up with least, yeah, the multiple is 2 by 2 by 2 is 8, and then divide that by the least common divisor, least common multiple. I guess you divide that by the greatest common divisor, which is 2, so you get 4. And so then you're multiplying by 4, right? Because dividing by a fourth. $375. I don't think that's correct though, because it's actually just 15 over 2. Yeah. A little confused here. Just a little confused. Maybe I need to divide by the, how did I even do that? Okay, let's try again. I think I have to write this down. This is just too much one shot. So, in theory, oh no, no. These all go to 30. One way or another. One way or another, these all end up at 30. Now the deal, which is 15, ultimately. So that seems to be the least common multiple. Now the deal is, problem here, the problem is each of these do what? Each of these two and a half, 5, 7.5. Let's think about this here. Let's ponder this for a moment or two. So what I was suggesting was if you take the denominator, right, you want to figure out, so this is already equal, you know, that's the thing. The least common multiple for this is 2. So you're already at 2. So what you would have done to get the least common multiple is you take 2 by 2 by 2 and then divide by the GCD of 2 by 2 by 2, which is just 2. So that's the thing. You get 8 over 2 is 4. Now that's wrong, right? That's actually incorrect. What? I thought the LCM and the GCD. Or just, I thought this was true. You know? I thought this was always true. Am I wrong about this? I mean, clearly we're wrong in this case, right? Because this is 8. This is 2. And this is also 2. Unless this is 4. No, it's not 4. Least common multiple of all the things that are the same as 2. This is not correct. Or this just can't be correct in this instance. If you had... Now what is interesting, if it was just A, B, it would be correct. So I guess this doesn't generalize as nice as I thought. It's kind of frustrating. It is true if you're dealing with 2 numbers, though. Which is weird. There's a way to prove this, by the way, also. Using the fundamental theorem of integers, arithmetic. The one that says that every number is a product of primes raised to exponents. This is true on the other hand, right? 2 by 2 is going to be, this is all 2. It'll be 2 times 2 is equal to 2 times 2. So you can do that. Fine, but now you've got, well, what are the other issues here? LCM, GCD. Okay, what do we do here? Yeah, I'm still thinking about it. I didn't know, you know, I was watching Wrangler Star earlier today. That was my excuse. It was with a podcast I was watching, and he was talking about moving out from the city, getting himself a plot of land with his wife. And I basically, like, I didn't know that he moved out from the city out there. I thought that, I actually didn't know anything about his shindig. I thought I was under the impression that he was always out there, something like that, which is kind of crazy. Because that was something I was thinking about doing, is getting out of the city and go get my own land. I'm thinking I should do that. Well, anyway, so LCM GCD issue here is A times B. So the problem is now we want to get the LCM of ABC. Now I guess LCM is similar to the GCD in that this is probably true. That you could take the LCM of AB, and then that'll also give you the LCM for C. I think that's true. So we can get this LCM of this result, and then we can say LCM of ABC is going to be the LCM of AB, C, which is then the LCM of AB over the GCD of AB, C, which is then equal to, which then you take this and you say this times the GCD of AB over the GCD of AB, C, equals the multiplicand of ABC over the GCD of AB, right? Which then gives you the LCM of ABC is equal to the GCD of AB over GCD AB, C, times ABC times the GCD of AB, which is a little more involved than what we had previously. This is a little more interesting. So this we expect 2. This will end up giving us 8 over the GCD of, looks like 4 over 2 and 2 GCD times 2, which gives us 8 over 2 times 2, which is 2. Huh. Let's call this LCM. The LCM okay. Right. So this is interesting. What do we make of all of this? 2 halves, 5, 7 halves, 15, 30 halves. So okay, well this gives us an algorithm to get the LCM. This seems like a lot of effort. Seems like kind of a lot of effort to do this. Yeah. the GCD of the LCM times this GCD again, LCM of AB, which is so. While I could calculate the LCM for multiple values, it seems kind of excessive. Seems a bit excessive here. Yeah. Can you recursively apply this LCM formula here? Maybe I can write an LCM routine. Maybe the issue I have here has nothing to do with. Well, I guess it kind of has something. I guess there is something to consider when you're dealing with ratios. It's like, this is an easy problem? I don't know, man. I wouldn't say that at all. So can you do. Well, basically it becomes this. You do have a recursive function sort of thing going on here. I mean, you can. Yeah, it's basically how you do it. You just take the LCM of the, you know, previous values and then apply the same formulation. So you do a kind of reduction, I guess, using the GCD. Yeah, that could work, I guess. The problem with this though is, like, let's say you did do this with, you know, 7, 5, 7, 2, and 3/5. So you've got this going on, right? The LCM of all of that, you're going to go, I guess, piece by piece with this GCD. And the problem that I see is, like, okay, so let's do 7 and 5/7, right? So the GCD, the LCM of AB with 7 and 5/7 is you get 1 over the GCD of 7 5/7. Now, I don't know how to calculate the GCD of a ratio and some other number, right? Something that divides both of them. I guess it's something that divides 5/7 and then also divides evenly. I guess dividing 5/7 means that it's some multiple of 7/5. Right? I think that's what that means. So, and some multiple of 7/5 that also divides 7. So I guess in this instance it would be, I don't know, it would be, I guess it would be, if you multiply by 5, right, 7/5 times 5 is 7 itself. Is that right? A 7th? LCM of 7 and 5/7? I don't know. No, I think it's the other way around. I think it's 7. That's super confusing, but I don't know. I don't think so. I think it's like, I want to say you multiply this by 7 and you get 5. Multiply by 7 again, you get 10. It's kind of like getting the LCM of just the numerators, which would be like 35. Is that right? I mean, I have no idea. It feels like you're just getting the LCM of the numerators. Ultimately, like I really don't know. And the LCM of 2 3/5 looks like 6. And then the LCM of 35 and 6 is exactly 210. No kidding. No kidding. Wow. Wow. Amazing. 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 That's crazy, man. So, I wonder. But what does it look like for, yeah, I really don't understand. 3/4 and a 1/6. 3/4 and 1/6. Now, I was thinking, so 3/2 is what ultimately you end up with. Which is strange, right? 3 obviously is a multiple that they both can reach, right? But they can they can both also reach 3/2. So I think when you're dealing with a ratio and a numerator, you're kind of forced to just consider the numerators. Well, not necessarily, right? I mean, you could have, yeah, no, I think it's it. No, I actually think it's right. When you're dealing with ratios, though, that's when you want to consider the denominators. I really don't know. The heck is the LCM with ratios? Maybe we get some explanation here. Vulgar fractions. Dyadic fraction, unit fraction, proper, improper reciprocals. Improper otherwise. Top heavy. All right. Decimal fractions and percentages. Mm-hmm. Shucks. All right. What is? I think I have to look at the answer. I gotta look. How is it? How's it even defined as the least common? Like I think that's the problem. Is I don't know what the definition is. Least common multiple when you're dealing with fractions. Like what would I have to? You could probably infer it, but I'd have to guess. And it's kind of like I don't know. It's kind of a lot of work to guess and infer it. Let's see what what's said about. I want to say I kind of already know what the LCM of fractions would be, but I don't have a simple formula to solve for this using the GCD. I guess that's maybe the other question. That's really the question I have, I think. Multiply numerator and denominator of the first fraction by the LCM of BD over B. BD over D. Multiplication denominator, both fractions are the same. Okay, so you want to make the denominators the same. Now, I think that's the problem I ran into. Okay, so, all right, never mind, I take it back. I had the right idea. The issue actually was that I had the right idea, but the issue is that in practice, the LCM by this algorithm that I was describing does not generalize nicely to LCM of ABC. The GCD of ABC is simple. Well, yeah, basically this algorithm that I was using based on the GCD to calculate LCM easily does not follow the way that I was assumed it to be. So it works a little bit differently when you're dealing with multiple mixed fractions. But the idea is correct as the same, that you basically set your numbers to ratios as well, reduced ratios, and you still calculate the LCM, and then you have to multiply by, so you multiply by a portion in order to make the denominator equal across the board. That's the idea. Create equal denominators across the board. And then what you can do after that is then you can perform LCM on the numerators. And then I think you divide at the end. So with this, as example, 3/4 and 1/6, you would get something like this. So you would say LCM of 4 and 6, which ought to be, I want to say, so that, which is 4 by 6 over the GCD of 4 by 6, right? Which is 12, right? And then you say multiply 3/4 by 12 over, I want to say, so you want to get 12 at the bottom, right? So really it's, what do they do? You want 12 at the bottom, right? So you multiply by 8 and 1, which is like 4 over 12. a little confusing. Yeah, I guess that makes sense. So you want that, and then you also want, right, this is a sixth multiplied by 6 over 12. These will cancel every time. So you do that, and you get 3 twelfths and 1 12th. Okay. Now the problem is you're actually multiplying by 12 over 12, right? So you don't really cancel these. You just want to get, so it's actually 2 over 2. And this is 3 over 3. So it's going to be 12 over 4 is this value. And then 12 over 6 is this value, right? And then you end up with 9 twelfths and 2 twelfths. Okay, that's really what you want to do. You want to multiply this numerator. You want to take these numerators and transform them. And you're going to transform them by the LCM divided by whatever this value is. That's actually what we saw previously. And you're going to take the LCM of each of those, I believe, which is going to be 18 over the GCD, which is 9. No, which is 1. So you get 18, and now you say, okay, we've got our least common multiple of the numerators, and got these denominators. I want to say we then just take divide by 12 and simplify, or divide both sides by the GCD of these two things. That's what simplifying does, which we remove 6, we end up with 3 halves. Kind of an involved process, kind of a complicated process here, but yeah, you end up, this is what you end up doing. And this is what you end up doing. Sheesh. Jeez Louise. Jeez Louise. Okay. Kind of involved process. Sure, I think. Can write a recursive LCM function to perform this. And then, so we get the LCM of the bottom values, generate the transform the numerators to the top values and get the LCM of those transform values, then reduce the technically what you do is you take the so you have this alpha, this, we'll call it A prime B prime, and you just divide both by the GCD of A prime B prime, and that's your result. I think, I think that you can do this sequence. I think you can perform this, but the problem you're going to run into is I think ratios in Clojure already are sort of self-reducing. Clojure ratio. Let's take a look. You know what just occurred to me? I think never mind. I don't know. My mind has been kind of conflicted. Could have been all over the place lately about thinking about women. There's this idea that's been kind of like stuck in my mind that a woman will not respect a man naturally who is not willing to do everything he needs to provide for her child. And I think that's reasonably true. Thinking about it, the more I think about it, it's like, you know, the choices I've made in my life and sort of the responses I've gotten from women, and I'm like thinking about it, it's like, yeah, I guess that makes sense. You know, I don't look like I could take care of a child, so to them it's kind of like not very attractive. I think it's interesting. Thinking about it, so I've been feeling a lot of insecurity lately, and I'm like wondering if maybe, well, I'm thinking about it, and I'm wondering what the deal is. Which is weird because I can provide, but I can't actually at the moment. I know that I can't in the way that's sort of the right way to do it. Like I can, but not reasonably, in my opinion, which is kind of interesting. One of the things that's been weighing on me for a while now. But I mean, I'm working on it. That's one of the reasons I'm learning Clojure. I guess, I don't know. I'm pretty conflicted. There's like a lot of stuff I can do, make things happen, but yeah, I'm kind of in this perpetual state of like conflict in terms of like what to do. A lot of things I can do. Guess I gotta do them, I suppose. I don't know if messing around with maths is the best idea given the desperation of the situation, what has become desperate. I didn't realize how desperate it is. It didn't occur to me till now that like, yeah, maybe I'm way more desperate than I realize, and I need to like change my mindset. Because a lot of stuff I've been thinking about lately. It's just like I can't like. I'm trying so hard to understand all of it, and it's very difficult, or has become extremely difficult to understand what the problem is, what's going on, what the problems are, the things that I experienced, like the pain that I've been experiencing, where is it coming from, why, all that kind of stuff. And I think it's because I've been living in like stark contradiction to reality, sort of contradiction to God's will, living in rebellion, and not just unaware of it, but unaware of how that would cause tremendous pain and consequences. Yeah, I'm kind of just realizing that while we're doing this, because I'm thinking about it. It's like, wait a minute. Because the thought came to my mind like, hey, this isn't really helping me. Messing around with ratios isn't really helping me, like, with that goal. Like, if it's desperate, then I should be treating it like it's desperate. Wow, it's pretty wild. It's pretty wild. You know what I can do? I can just go in the line REPL. Yeah, the expression "daylight's burning" here is coming to mind. Thinking about this position I found myself in now, if it's desperate. All right, so class 227. So if we do 227, right? Okay, let's do. All right, let's do let's multiply by 2, right? So 227 becomes 4414. Ah, it does automatically reduce. Okay, so we don't need to do that GCD calculation I was describing previously. Thinking about it now, it's like, wait a minute. So what should I be doing then? Maybe. Let me like slow it down. Slow down a minute. So what Wrangler Star was suggesting, he said, hey, you should not try to force this also when you're looking to move out and build your own house. You should take it slowly. You should go sort of let God guide you, something like that. Don't force it, because then you're going to end up, it's going to be very difficult, very painful. You got to put your faith in God with this. And he's saying like things that could have taken ended up taking us years, you could have had done in a month. Kind of a suggestion, and I was thinking, okay, that's probably fair. What I'm considering doing is, what I'm thinking about doing is like, well, actually no, I think the best thing to do would be to find a remote position, a remote job. There's like a few different ideas, right? Like, I think finding a remote job is the best, actually. Because what I can do is if I get something remote, then I can go wherever I need to go, and I can actually work simultaneously. I can work remotely and work on the house at the same time. Maybe that's the best. I'm thinking like, because then I'm thinking like heeding his words. Like, what does that mean? How does that work? Like, probably what can be done is, if I'm going to get another job, I probably should get another job as soon as possible and work remotely. That's probably the thing to do. And then from there, and don't force it, right? Go slow. And then from there, I can move. Even better than that, though, if there are like, I can make videos on the internet, and try to draw some attention. I've noticed a few videos that have been gaining some traction. So I could sort of work more on YouTube videos that people might want to see, might want to have, and actually build something out of that, a small income. And then that's remote, and it's kind of difficult to, or not that it's difficult, but I'm not like necessarily employed, so I can kind of work on what I want to work on and work on that simultaneously, and build an income that isn't dependent on anyone or any location or anything like that. So that could be a better option even. That would take some time, but that'd be even better than just like leaving. Because I'm kind of like up Poops Creek without a paddle if I don't sort of do this gently, or sort of deftly, gently, with a bit of caution. Do it sort of, what's the word? With a degree of care, do this carefully, this whole thing. But I can figure this out. This can be done. And man, what they were describing about how they live their life, Owen was talking to Wrangler Star about what they've been getting up to, and I'm like, yeah, I see it, man. I get it. I understand. I agree. I think it's a good idea. Get out of debt. Get onto some property, and start living for yourself, working for yourself. I think it's ideal. And they were suggesting just get a small plot of land to start with initially, which I think that's a fair point. I think that's a good idea, because you really don't need a lot of land anyway, especially if it's just me alone. Like, I don't need more than just an acre or so, was what they were suggesting. Which I'd like to have a lot more than that, but yeah, I think Owen only has 6 acres, which I got the impression like he had like 100 or something, whereas Wrangler Star did have 100 acres. I thought, holy smokes, man! If I get 100 acres, I get my family and my friends. I get everybody out up there. I get everybody. I have a bunch of close friends that are living here that are living like they're living like I am, which is not ideal, and I'll get them out there on that property, 100 acres, and then I'll get my brother. I even met both my brothers. I'll probably get my older brother definitely, and I'll try to get maybe my mom and my sister out there. And I'm not sure if my dad will be around for all that. Maybe he will, I don't know, by the time we get 100 acres, but oh boy, oh, that'd be great. That'd be fantastic. Just build houses for everybody on the land. I would love that. Start with 1 acre and just build it up from there. Yeah, that sounds like a dream come true. That sounds so good. That sounds like a dream come true. Man. I have a coworker too. I should keep in touch with him. He was chatting about, his family has some property upstate. That's like, it was like all wooded. This property, and they've been working on it slowly over time, and did not have a lot of resources to work with. But here's the thing though: if I work remotely, I can get resources together. I can do things. And I've been yammering on about I sort of quote unquote business ideas, which are like things I can work on, but probably better to work on like getting myself out of the city, getting myself into like something remote. There's a lot of stuff to do, but I have loads of ideas of things to do, man. It's crazy. It's ridiculous. I can't deal with it all, man. It's nuts. It's really nuts. It's just so much stuff. Things to do. And some of these things are worth like billions of dollars. Just like how do you contend with all this? It's crazy. That's what it is. It's crazy. Anyway, let's try to implement this algorithm before I lose my mind with all these things to think about. There's too much stuff to think about, man. Too much stuff to think about. Yeah. So we can write a recursive LCM function or reduction, more like an LCM reduction, variadic LCM function, and we can write our GCD functions also variadic, and then we can say, okay, the algorithm is going to be for integers, right? LCM function for integers, and we're going to say, okay, for ratios, everything gets converted to a ratio. We take the denominator of all these things, and then we take the LCM of the denominators, get some value, and then say, okay, apply the LCM over, I guess we'll call it the denominator divided. Yeah, so it's going to be the LCM divided by the denominator of, you're going to multiply the numerator of each value by that amount to get another value, get some sequence of value numerators, modified numerators, then take the LCM of those modified numerators, and then take the LCM of the modified numerators divided by the LCM that we calculated, and that's going to be, and then that ratio will be simplified automatically by Java, by Clojure, and then that's our least common multiple. Why is this considered an easy problem? That seems crazy to me. Why is this an easy problem? There's no way this is easy. I wouldn't call that easy. All right, let's do it. Let's write it locally first. There's going to be 5 examples. We'll grab each of these as well. Yeah, man. I mean, I think, like I was thinking I should, start dating and all of that, but maybe it's better, get myself out of the city, focus on that, and I can date. I don't know who I'm going to date or how that's going to work, but I can figure that out later, I guess. I think if I've got a place, I think a woman will be interested. Could find one who'd be interested. I don't think I'll struggle too much with that. once it's clear that I can take care of things. And what is it? "Quote unquote masculinity is restored," something to that effect. I'm not doing this sort of degenerate city lifestyle where I'm like corporate wage slave, whatever you want to call it. All right, let's say ratio LCM. Okay, and this will take a bunch of arguments, ratios. And we've got this let, and we'll say int LCM. Right, write this recursive function that we'll describe shortly. GCD, int GCD, or just GCD, which we'll also describe that shortly. And then we've got the ratio LCM will make use of both of these, and that'll be the function we want to use. So let's start with so GCD will take AB, be variadic, right? So you've got two of these. You've got one version. Can we do it this way? Hold on. Okay, let's try this. So you've got this function here. I want to use different parameters for each. So if you said like AB, right, and then another function that took AB args, 1, 2, or more, right, more than 2. Then you would say, let's just return immediately, A plus B, or just AB. Say, yeah, like a vector AB. And the same thing will be vector of A, B, and args, right? Does this work? Yeah, I basically should view where I'm at in the world as like, it's time to find a wife. And everything I'm doing right now is just to provide for my family, and that should be the correct view of things. Which is the view that my I guess is sort of like a mentor, one of my friend's parents had or has. Yeah, there's definitely, it's a lot of like, I don't know, man, like, gotta commit or something, Oh, let's go back here. Yeah, actually, no, let's go back. That's fine. The way they were describing this lifestyle was like, oh man, gotta get out there. Gotta get going. Okay. So this is exactly what I need to do. All right, interesting. So 2 different functions. This gives us the arity. So we'll define this GCD function recursively. And actually we can leave this open for testing, I guess. So the GCD of AB is going to be basically you recur on, you say if 0 of A or 0 of B, then you return A. Otherwise, you're going to recur with B modulo A mod B. B with A mod B. Yeah, that's what we want. Right? Then you're going to say, if you're given a variadic sequence, or you're given a bunch of stuff, you're going to return GCD of AB and the GCD of with the first of the arguments, or GCD of first of the arguments, and then finally GCD of the rest of the arguments. And this will create a call stack, which we don't necessarily want to do. We can probably do this recursive. We could probably use this as a reduction, I guess, which we should do as a reduction. So let's reduce using GCD of first GCD of AB, right? That'll be the initial value here. And then we're going to say, this is actually the way to do it, I think. So basically, you call GCD of AB, and then you apply GCD of that result to one of these argument results, and then you just keep applying over and over again. This is what we want. Yeah. If you have more than one. All right. So that gives you variadic GCD for integers. Now we want a that's int GCD. Then we want int LCM is similar. Basically, we say there are two possibilities. It's either variadic or it's not, right? So AB does something, and then, right? And then we also have AB arguments, right? And what we're going to do, look to do, is AB arguments. What are we doing here? Integer LCM, AB arguments. What are we doing? Oh yeah. This is the product of AB divided by, and this is a ratio we want, divided by the int GCD of AB. And we can put this in GCD up here. All right. Okay, so and then we can say similar reduction. And this isn't just GCD, this is int GCD. Right? This will be int LCM over, yeah. So this will automatically apply this recursive kind of thing, right? So we don't need to like because you can expand this recursion and it's pretty ugly, but if you write it this way, then it's actually pretty manageable thing. And this also avoids using any call stack overflow, any stack. So there's no stack overflowing. All right, sweet. So we got our int GCD, we got our int LCM, and now what we're going to want to look to do is what? GCD LCM. What's the last thing here? The ratio LCM is the one that's kind of interesting. So the way that works is effectively now, I'm not sure if we need to do multiple functions for this one, but the idea is going to be you got the numerator, so you've got these denominators. And excuse me. You've got the numerators, you've got these denominators, and what you're going to want to look to do is find the LCM of these denominators. Then for each ratio, multiply by the LCM, multiply the numerator by the, or let's map the numerator of each of these ratios to the LCM that we calculated. Multiply that numerator by the LCM that we calculated divided by the divisor. Is that right? It's a little confusing. The LCM divided by the divisor, or the denominator. Multiply that by the numerator. Wouldn't that just be multiplying like by the fraction itself? Took 3/4 and multiplied by 12. No, it's not, because it's no, it is. Wait, what? It's just 3/4 over the times the LCM. Yeah, no, that you just okay. You map each of these ratios times the LCM to get the numerators, and then no. Well, yeah, no, yes, correct, yes, that's what you do. Okay. Then you get each of these numerators. Then you can okay. So you take the ratios, multiply by the LCM. That gives you these modified numerators. Take the variadic LCM over all these numerators, which you can use the int LCM. Then what you're going to do is then create a ratio of what you got, the result of that divided by the LCM. That's your final ratio. All right. Pretty wild, man. Yeah, this is fine. We can do variadic number of arguments. Should be at least 2. And we'll say, also I probably should test some of this code a bit. Maybe I could do that. Let's do that now. Ooh. Excuse me. All right, how are we doing here? Unresolved symbol in GCD in this context. Excuse me? It's right here. Oh, F. Oh no. Oh, you're kidding me. That's not good. Oh, no, that's fine. We're good. That works. Could also call this F while we're doing this here. All right, give that a shot, see how that goes. See how this goes. 1-1. All right, nice. That's what we want. So these seem to be working properly. So let's even do int LCM. Just try that. So what do we get here? 12. Nice. Okay, cool. So now what we want to do is, right, so the way this is going to work is, I call this F2 just so it has something to refer to. So now what we can do, AB args, we want to say ratio LCM. So what we do is calculate the LCM of the denominators of all of these things. So int LCM, now can we, how do we do this? We can do something like this. Let's use a let. Probably simpler to use a let. Say just args, or I don't know. Args2, arg something, I don't know what to name this. Temp args, or just total args, all args. Do it that way. Cons B of args, and then cons A of args, right? Doesn't really matter, but we want the sequence of all of the arguments. And then we want to say map, so apply map, or yeah, apply, or really just map, what would be the denominator? What's this called? Ratio, get denominator, Java. Let's see. That's not what I'm looking for. Clojure is really what I want. Denominator. Okay, nice. So we're going to map denominator of all args and provide that result to this int LCM. We'll call that denom LCM. Right? And then we want to say take all these arguments, apply this partial, just multiply this value by the denomination denom LCM over all the arguments. Right, so if you do this, you get this denominator LCM, you multiply it by each of these values. This will give you the numerators, the special numerators, and then we want to get, again, apply to int LCM these special numerators. This will give you the denominator, or the or numerator prime, we'll call it, or P, or just I don't even call this. It's like the next numerator, just num. We'll just call it num. So after you multiply all of the arguments by that int LCM of the denominators, you get something special. Then you can call the int LCM of this result to get the numerator, the LCM of the numerators, and then you're going to return the division of this numerator by this denom LCM, which will also be automatically reduced by the greatest common divisor, automatically simplified by Clojure. So ratio LCM, I think is what we're going to want here. And so we just call ratio LCM. dividing, after figuring all this out. All these arguments. Should be at least 2, should just be AB args. Alright, see that. Let's see it. Let's go. I could probably write like a regex, like I said, I probably could write a regex that would, using back references, that would quickly replace this portion. Actually, no. Oh yeah, replace this portion with what I'm looking for. What do we want? We want print line of, what do you call this? Oh, maybe I don't need much of a regex for this. I'm thinking about it. Ratio LCM. Oh, they're both called ratio LCM. Okay. Nice. Does this work? Can I do this? Also, I think this needs to be beneath the other ones. I don't know if this will work. Could try it. I think it does. No, I think it's bad. It was just call this local. Just to keep it not super confusing. No, the piece that I'm missing is this part. You gotta have, yeah, using a back reference would work, but you need this extra parentheses at the end here. Alright, let's see how we're doing here. See how we're doing. All args failed. Nice. Alright. Cons be args. We can just return nil, right? Doesn't matter. Clojure will be okay doing this. Let's see how we do. Nice. Null pointer exception. Why though? Why would that matter? Does this matter? Shouldn't make a difference. What's going on here? Okay, good. Alright, so we can confidently state that the issue seems to be something else going on here. So if we do all args, cons be args, all args. So something failed with all args, right? That was the suggestion. Fail the vector binding spec. So this is a vector. Is that what they're suggesting? Doesn't really matter if you can conjure or cons, but what you're telling me is these args are not a no. Excuse me. Binding spec. Oh, that's why. Yeah. See the problem. It's nothing to do with cons or otherwise. This is just oh, no, this is fine. these are supposed to be bindings, and yeah, it's just the let form. Sometimes I screw that up, the let form, the form of the let. Definitely make that mistake every so often. Let's try again. See how we're doing here. Interesting. Interesting. What if we just do this one? Oh, I think that's actually, I think I know what the problem is. Yeah, I think I know what the issue is. Convert all these arguments to ratios first. Rationalize. Is that what I want? What happens if you rationalize a ratio? What happens if you rationalize a ratio? And the guy says, oh, I know this one. Nice. Rationalize 1. Rationalize 1 divided by 2. I see. 1 over 2. Interesting. Don't know this is gonna go. Oh. Don't know how this is gonna go over. Let's see. Long cannot be cast to ratio. You're kidding. You've got to be kidding me. Come on, man. Doesn't work for all numbers. Oh, I should have realized this. More generic solution. Numbers to ratio. Nice. Where is Richiki? Numerators should be fixed since integers are also rational numbers by definition. The latter type safe beam. Yeah, that's interesting. On the dev side. Patch reverted. Oof. What happened? All right, I don't know what's going on. Oh, Atlassian. Okay. Right. So, Clojure numbers despair. There's a 2 ratio, but I don't know if I have that available to me in the inside here. I have to test that. That would be kind of unfortunate if I don't. So let's go back. No, where's the overflow post? No. Close all this junk, man. Overflow ratio, Clojure ratio. Okay. Excuse me. Yeah, is this the right one? I think it's this one, yeah. Okay. Oh, man. Clojure line numbers 2 ratio. Okay, can we try that? Get the REPL going. Kind of an involved thing we're doing here. Alright, got it. So, do we need to include Clojure lang? Nice. You've got to be kidding me. So I think we need to include this, which is really annoying. Clojure.lang.numbers as clnum. Let's try again. Just go again. And we go again. You're kidding. Maybe it's not. Maybe that's not what I need. What's the problem here? Exactly. What's the issue? Unable to find static field. 2 ratio in class Clojure.line.numbers. Static field. Doesn't make a lot of sense, right? Because I can use this directly. In the REPL. You're kidding. Maybe the issue is something like this. I mean, this should not be an issue, but try again. See how we do. syntax error. Null pointer exception. Full report. I mean, okay, I guess. You gotta be kidding me. What do you mean null? Where's that coming from? Is it this? It's null? You're kidding, it's this? Yeah. No. Okay, so that happens later. What is happening? Where is that happening? No point exception at... What do you mean? These aren't even called, these other functions. So there's something real funky going on here. I guess this will give you a null pointer exception. Maybe that's the problem. Okay, I think I understand. So maybe this works, and we just need to, like, I don't know. I mean, I really don't know. We could throw a test in here. Maybe that's what I need. See what happens. Parental line might be incorrect as well. 2, 3, no. So this gives me null pointer exception. Come on, man. Come on, man. This is apparently a null pointer exception. Why? Why though? Clojure.lang.numbers to ratio. Can't use the Java interop properly. This is depressing. Come on. Okay. Who knows why? It's nowhere to be found. Nice. Numbers, Java, Clojure lang, numbers. It's right there, man. Warm boxed math. So this just doesn't work for reasons that are beyond me. Unknown, unclear reasons. This just does not work. Why though? Can I just say numbers or just Clojure? What about that? Clojure.core, Clojure.lang, Clojure.numbers. Come on, man. What is going on? Why? 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 Unable to find static field. Alright, we're gonna have to. This is It's not copacetic here. Gotta figure this one out. What is going on, man? What is going on? Following piece of code. Fairly thin abstraction over the JVM, and there is no such thing as a first-class method, so a method can't be an argument to a Clojure function. That is, on a bytecode level, method can't be an argument. Come on, man. For idiomatic forms for accessing field or method members are given above. Instance member form works for both fields and methods. The instance field form is preferred for fields and required if both the field and a zero argument method of the same name exist. They all expand into calls to the dot operator described below. Macro expansion type expansions are as follows: class name static method args, class name static method args, class name static field, class name static field. So you should remember that class field name is just sugar for getting a static field. Neither static method call nor reference to the static method. Java method is not a Clojure function, really. Oh, so there is no static field in integer class, while class field name arg calls a static method. They are two totally different operations using the similar sugary syntax. So when you do map parseInt, it expands to dot integer parse. You can easily see for yourself. Macro expansion of map parseInt expands to dot integer parseInt. Fails when it's trying to get a field, which you think is getting a reference to a method. Oh. Okay. So how do I? It's kind of complicated. I guess this is what I got from all that. How do I type as a function? The JVM doesn't support. Okay, got it. So the thing is, I need to find this. So this field, right? So this public static ratio to ratio object. So I want to call this thing Clojure lang numbers to ratio. Okay, so clearly we want to wrap this. That's fine. All well and good, but then we can't seem to find it even though when we map it. Oh, it worked. It's just it's literally a null pointer exception. Like, you're passing nil, which is not an object. That's the problem. Oh, got it. Oh, you gotta be kidding me. Okay, well that makes things a lot easier. It's just not equal to nil. Okay, that's okay. So actually, it's not quite what I thought it was. The problem was not quite what I thought it was. And maybe spell things correctly, that would help too. Holy guacamole! There we go. Syntax error. Arity exception. Number of arguments. arguments passed to ratio LCM. This could be empty. This is fine. Are 2 arguments passed to. Can I not do? Does that work? Symbol B in this context, I think. I don't know. Oh. Is this? Am I going crazy here? What? Wait a minute. Go back. Hold on, try this again. Wrong number of arguments passed to ratio LCM. 2, 3, 2, 1, 3, 1. So 2 arguments was okay, but 3 arguments was a problem. Now, I don't believe you, right? Oh, it's probably because of, oh, I think I see the problem. Okay. I think I see the problem. Let's see how that goes. Let's see how that goes. Oh, come on. What? That is just so confusing. What are you talking about? What are you talking about? Is this the one that's got the wrong number of ratio elements? Hold on. What are we doing here? What are we doing here? Okay. 2, 1, 3, 1, 1, N. What does that mean? 1, N. What? Denominator LCM. You're gonna multiply these things? Is this the problem right here? You're kidding, right? Why would that be a problem? Also, yeah, this is taking, it's going nice and slow, this whole process here. So yeah, this has an issue. What is this 1n? Also, why is this giving me that? If we apply to int LCM map denominator to all these arguments, int LCM should return a something. What the heck is this? Alright, let's try this again. Okay. What do you mean? Oh, that's why. Gotta print it. Of course. Was not expecting this to be this challenging. I guess it's got more to do with, like, I don't know, familiarity with Clojure. So yeah, okay, so we got the 1 1. All right, that's fine. But what is this 1n? 1n. Why is that? I don't understand that. Int LCM of 1 1. In GCD 1 times 1 of 1, like, what is going on? Why are we getting 1n? Divide 1 by 1? Should just be 1. Why is there a 1n? What the heck am I looking at here? Apply int LCM to denominator. So the denominator works okay, right? We get the 1 1. That's fine. But we print this denom LCM. We get 1n, which doesn't make any sense to me. Why would this int LCM give you an n? Where's that even coming from? Is it, are we not applying this function? Calling this int LCM? What does this even mean? Do I have to explicitly convert these things to integers? I don't know why you'd need to do that. That's so weird. I don't understand. I don't get it. I'll be blunt. I do not get it. Do not know why that would matter. I suppose that's fine. Syntax error. Okay. Alright. So denom LCM is a 1. Gonna multiply 1 by each of these arguments. So we apply to each of these arguments this thing times 1. Then we apply int LCM to the result. Each of those values, which these I think also need to be integers. Yeah, that might be part of the problem. Now that we're looking at it here. Well, also, maybe not. May or may not be related. May or may not be an issue later down the line. But definitely this Parity exception, what does that mean? The ratio LCM. 2 arguments passed to this anonymous function. Why would there be 2 arguments passed? Isn't this just... Why would this matter? Shouldn't this be 3-1? Yeah, convert this to ratio. Shouldn't matter, right? Is that what happens? This no, I'm sorry, it's not apply. That's why I'm getting confused now. Map is not the same thing as apply. Okay, got it. Cool. Looks like it works. Okay, that was a little involved. It's a bit of a doozy. That was a bit of a doozy. I don't want to call that an easy problem, man. Or at least that didn't feel too easy. That felt like a lot of stuff. Maybe it is easy, I just didn't realize it. I don't know. But I don't know, man. That took me a while. Oh man, I think we got it correct here. Holy smokes. Holy smokes. Wow. What do other people do? GDC. Nice. You're kidding. So they didn't do any of the math that I did, looks like. Some of these folks. They just went ahead and said LCM is going to be, you get GCD, so define GCD, and then say reduce over using this function. I don't know. Oh yeah, it looks like this function with no initial state, I think. That's confusing. What? What's going on here? It's supposed to be two things, right? The X, I guess, is this is the oh. So yeah, there's no initial state. Okay, interesting. So GCD will just return a value. All right, I guess that's fair. And we say given two values to reduce over. Yeah, that's fine. That makes sense. The initial value and the next value. The initial value being, I guess, 0 or something. I don't know what the initial value is going to be. How does this work? This I don't understand. This I don't understand. How does that work? What is going on here? What is happening? LCM in this context. So this should give us 3, 2 at the end there. Or 2n, it says. I don't know what is going on here. 2n, it says? Oh no, it's supposed to be a 2. Yeah, no. Give me something else. Give me like one of these other ones that doesn't give you a number, integer, like 3/2, right? So 3/4 and 1/6. Let's see that. All right, let's see that. 3/2. You're kidding. Son of a gun. Wow. What? Is that a joke? Well, X is a sequence, right? So I guess it makes sense, but if you... Yeah, I guess... Oh, no, it does work. Yeah, because you... Well, no. No, what do you have initially, right? Like, what do you... Let's do this. Let's just test, right? Test, print line, GCD of... Oh, I think reduce automatically takes the... Oh, I'm sorry. Never mind. It's my own misunderstanding. My own misunderstanding of how reduce works. Duh. I forgot that. Works like that. You actually don't need this. Both of these are unnecessary. These are all unnecessary. Of course. Of course. Oh man. That's why you do these exercises, man. That's why you do these exercises, because reduce will automatically take the first 2 elements if you don't provide it a oh, or maybe it won't. What? Let's go. Wait a minute. What do we... Alright. Oh, no, never mind. We do need those. I mean... Yeah, alright, never mind. We'll just leave it. It's fine. But yeah, the reduce will automatically take the first 2. Okay, got it. Duh. So... Oh, this calculates the LCM of the first 2. So this is all wrapped up in one shot, the whole LCM function, the recursive LCM. But this works even if it's rational numbers. Multiply the 2 divided by the GCD. Like, what do you get if you try to GCD 3/4 and 1/6? How does that work? Yeah, what? What do you mean? Wait a minute, what? This just works? Are you kidding? What is this? What happens when we do this? There's no way that makes any sense. There's no way. How does that even work? Are you kidding? Is that a joke? 3/4, that just works. You could just GCD, boom, no problem. Is that a joke? Is that a freaking joke? You gotta be kidding me. Oh my goodness. Talk about doing extra calculations here. What in tarnation? So apparently you can do this with arbitrary. This don't need to be integers, x and y, to take the GCD. You can take GCD of rational numbers. If y is 0, so 3/4, 1/6, you can recur with 1/6, and this is 3/4 modulo 1/6. How does that work? So apparently you can do that. apparently you can take modulo 3/4 1/6, and I guess you get a 12th. Or you get, I don't know what you get. You get something. You get a 12th. Holy smokes. No kidding. I don't know how that works. That's amazing. Okay, well, that's useful. That's unbelievable. All right. What? I didn't know that. That makes life a lot easier. Makes this problem, I guess that's why this problem is an easy problem. Not that easy if your modulus doesn't operate on rational numbers. It works for float and doubles too. It's defined as this. No kidding. That's amazing. Takes on a new definition altogether. Yeah, I guess I should have known that. Well, now I know. Float and doubles as well. Subtract from n the floor of n over d times d. Amazing. I don't exactly know where this came from or why it's this, but I'll keep that in mind for the future if I ever want to know what the deal is with modular numbers of doubles. So there you go. Actually, you can use the GCD of doubles, and then this actually becomes trivially easy, right? It becomes just a recursion on the LCM, reduction on the LCM. Well, that changes everything for me. You gotta be kidding me. Yeah, alright. Pretty much do exactly what was just done there. GCD, function, take args, or yeah, just A and B even. Don't even need to. If 0 of B, turn A, otherwise recur on B mod AB. There you go. There's your GCD, and then you can reduce over the arguments using very basic first multiply A and B, and then you're going to divide that by the GCD of A and B. And it'll be 1, 2. 1, 2, buckle my shoe here. Obviously you can save a character on the 1. But yeah, it's almost exactly what we just saw. You've got to be kidding me, man. You've got to be kidding me. Let's see that go. Let's see that. Wow. It's a good thing I'm looking at what other people's solutions are, because I remain more or less ignorant. A lot of these better solutions, what they look like. Because I just don't know, man. Some of the stuff, like I didn't really know that this modulo worked. I mean, I worked it around as if it didn't work for doubles. I don't think modulo works for doubles in C++. Modulo almost certainly doesn't work for almost certainly doesn't work for doubles. in oh, cool. It's kind of, oh, it's not, interesting. Yeah, almost certainly doesn't work for doubles in C++. I guess, I mean, I guess you could define, right? Yeah, okay, interesting. I don't know what to make of all that. But maybe it does. Maybe it does work. Well, let's find out. Let's see. We can just look. So there you go, that was my solution. Let's see, modulus. Oh, yeah, okay, I guess it does work for arbitrary templates. Yeah, it's templated modulus. Interesting. I mean, okay. Modulo, let's see. Yeah, maybe it does work for doubles. I don't know. Amazing. Amazing. Maybe I should just try it. Pop open an IDE. I don't want to open up freaking Visual Studio Code just to try out some C++. Let's try some older C++. See what happens when we do this. Aha! I thought maybe that was the case. Yeah, in C++ it's almost definitely not. Definitely not support. Yeah, that's what I was thinking. Okay, so me coming from a C++ background, I got to run everything through as if you've got relatively not that you have limited functionality, but you've got to like very explicitly define the functionality that you want. Like if you want this thing to work on doubles, you got to define it for doubles, and then probably overload the function to work on doubles. Whereas in Clojure, apparently they've done that for you ahead of time. Just sort of not something I'm used to coming from C++. So the code I wrote would have worked if they only operated on the code I wrote originally would have worked if they only operated on what do they call that, on integers, right? If we had to, if we didn't have a definition for doubles and rationals, code I wrote originally would work fine. Whereas it's made much shorter if you already have overloads for rational numbers as well as double operations. Amazing. Amazing. Okay. So let's all right. I think we'll end it here. Thanks for watching. Talk to you all soon. I think I'm gonna just end it and then probably go to bed. I don't want to spend the extra couple hours or whatever programming. Kind of just want to get some sleep. But yeah, just one problem, 2 hours. Not bad. Not bad. Learning all kinds of stuff about Clojure. It's Levenstein distance. Given two sequences x and y, calculate the Levenstein distance of x and y, and then a number of edits to transform x into y allowed edits are single item, delete a single item, replace it with another item. Some of these test cases may time out if you write an inefficient solution. Neato. Yeah, so we've looked at Levenstein distance already. We looked at a variant of it. We didn't actually implement it, but this shouldn't be too bad. There's an article online we can look at to do a linear time complexity. I'm probably going to ponder like a dynamic programming solution. I'm probably going to ponder how I might program it without looking at the solution first, but then I'm just going to defer to the solution because there's not really much of a reason for me to exacerbate this. And like I said, I'm thinking I should probably push to solve as many problems, solve these as quickly as I can. There's about 55 more problems, 56 problems we got left. Solve these sort of quickly if I can, and then look for the next thing. I guess I'll be looking for remote jobs. I don't know, and or building like YouTube, sort of making YouTube videos. There's a few ideas I've got for things I think people would be interested on YouTube. One of them being like, I know people seem to like to watch solving like the very hard problems online, and I've solved many of them. I mean, years ago I solved some very hard ones that I can post online. Yeah, solving the very hard like interview questions, I can put up loads of those. I have also questions from like way back when I was younger, like 6 years ago, solving problems. I could put them up online as well. And then I was thinking about writing like some machine learning programs that do certain things that are kind of neat. Like one of them would be like a machine learning program that solves like games, like plays games, specifically leaning towards like speedrunning older games as an example with a machine learning program. That would be kind of neat, I think. And then I can also write, that's one thing I was thinking about doing. I think people would be interested in that. And then also, yeah, the hard sort of interview questions. And I could be doing all this stuff while I'm interviewing at places as well. Like, yeah, try to do these things in tandem. I think it'd be good. And then eventually once we get enough income where I don't need to be like at an office, and I can kind of like take some time to work on things, then I can start looking at, and I'll probably have some income built up by then as well. Then I can start looking at property to maybe I'll lower my standards a bit and say like just a few acres, and kind of I wanted to go out to Tennessee, and I'm thinking like, yeah, well, why not? If you're gonna go out there, you should properly go out to get like an acre first to start with, build some small cabin type of deal. I can live stream that, all of it, the whole process, or just video record the whole thing. And sort of build the old YouTube channel same way, same deal, and go build myself a spot, and that'd be interesting. And then I could look for like a proper like a big piece of land somewhere to move into once I've got like a small home built. After a year or two, living on my own house, my own income with plenty of resources and all that. I could also start dating too around that time, I guess. Start dating, build a house. Yeah, figure things out. I think that's a good idea. Yeah, because I'm under the impression that like women are not interested in me because like I don't really have I have the means, but I don't really have enough to like really provide for a family. And I think they catch on to that and they're aware of it, and it's like, could do better than that. And also like it's just not good, man. Like it's just not a way to live. Like the way Owen Benjamin was describing it, the way Wrangler Star was describing it, it's like, yeah, you come in after a long day of work and your wife has made food and you got your kids and you just all gather around and eat, and it's the smells and the joy and the warmth and all of that. It's like there's nothing else in the world. I wouldn't give anything in the world for that experience. And I'm thinking about it like, yeah, That sounds pretty good. Like, I don't think it sounds like something that money couldn't buy. You know, it sounds like something that I don't care what you do. Like, there's no replacement. Like, that's it. Like, that's what you want. And also the idea of like working with your kids. You know, like getting them involved in stuff, and just like learn things, they can spend time with you. That sounds really good. Sounds like a really good idea. And I didn't know that Wrangler Star was like a born again Christian that decided to leave the city and go start his own life. Like, that's exactly what I want to do, man. I didn't even know he did that. I thought he was just like a Christian and he was out there. Like, I got this impression like he was always out there. I'm like, holy smokes! Like, that's amazing. Wow. Anyway, okay. So let me go. Let me go. Thank you all for watching. I'll talk to you all soon. Probably gonna like mess around for an hour, go browse the internet, and then go to sleep. And tomorrow will be interesting. I'm gonna fast tomorrow. Go take care of some things. Get my laundry. Get some water bottles. Get some milk for the week. And then I'm going to look to. We'll keep working on these problems tomorrow. I think we'll just keep going. Yeah, just keep working at it. Just keep grinding away. I don't know. Yeah, that's it. We'll just keep grinding away. It's fine. There's nothing else to say other than keep grinding, and eventually we're gonna look for we're gonna try to build something that we can make income like passively through the internet, or actively. I mean, if I just have a job that I work 8 hours, get paid like developer salary, and it's remote. That's perfect. I don't need a lot. You know, as soon as I leave New York, and my vehicle's got 2 more years on the lease, so basically I can just buy whatever I need, you know, and then once I build a small house, that's like, you know, very easy living. Basically, not easy living, but I can slowly kind of mesh and mold my way through. I have the resources to buy the supplies I need, and yeah, you know, I'll figure it out, step at a time, one step at a time. But definitely, yeah, man. Oh man, the dream. Go get yourself 100 acres somewhere, and whew. Oh man, that'd be so good. All right, let me go. Let me get going. Take care. Talk to you soon.